Welcome to this revision lesson session of A-Level Statistics, GCE 2021 Paper 1 with Was Moses, a mathematics teacher. Before you begin this revision lesson, click on the red button below written subscribe for more future lessons. This exercise is for those who are not yet part of my channel. Okay, we are good to go. The lesson begins for everybody. Pure Mathematics with Statistics, GCE 2021 Detailed Solutions, A-Level, Paper 1, Multiple Choice Question. Directions. Each correct alternative from A, B, C are circled at the end of every solution. So after solving each question, you look at this alternative and the correct answer will be circled at the end of each question. This paper normally consists of 50 questions, but question 1 to 35 are mainly concerned with the pure mathematics part, which was already solved. So there is a paper in this group of videos on the channel labeled Pure Mathematics Advanced Level 2021 Detailed Solution. That is the first part of this paper. Now, here we'll only be concerned with section B, statistics, for those offering mathematics with statistics at the advanced level. Question 36, we continue, we begin. The probability distribution of a discrete random variable x is given below. X equal x, density PDF, piece of x equal x. When x is 2, we have 0.5. When x is 3, we have 0.3. And when x is 4, we have PDF 0.2. The expectation of 2x minus 3 is solution. Now, properties of expectation says that when we have an expectation, we are looking for the expectation of 2x minus 3. It will be given by the 2 times the expectation of x minus 3, since the expectation of a constant remains that constant. But the expectation of x from formula is calculated from the summation of all x piece of x equal small x. Now, to do this, it means that we need to create a rule for x piece of x equal x, and we simplify. When x is 2, 2 times 0.5 gives 1. When x is 3, 3 times 0.3 gives 0.9. When x is 4, 4 times 0.2 gives 0.8. Adding up all this to have this summation, we have 1 plus 0.9 plus 0.8, which gives 2.7. Now, substituting 2.7 as expectation of x in the first expression, we have 2 times expectation of x minus 3 to be 2 into 2.7 minus 3. This is equal to 5.4 minus 3, answer 2.4. Answer Z. Question 37. The cumulative distribution function f of x for a discrete random variable x is given below. X, when x is 1, the cumulative is 0.2. When x is 2, we have 0.32. When x is 3, we have 0.67. When x is 4, we have 0.9. And when x is 5, we have 1. The probability of x equal to 4 is solution. Given any cumulative distribution function f of x, we know that to find the probability of x equal a particular value, x, we should always take the cumulative function of that x minus the cumulative function of the integer just less than that x by 1. So the previous integer less than x. Thus, the probability that x equal to 4 is equal to the cumulative distribution function of 4 minus the cumulative distribution function of 3. This gives 0.9 minus that of 3, which is 0.67, giving us 0.23. Answer B. If the probability of B prime intersection A is equal to 3/20, and the probability of A intersection B is equal to 1/4, then the probability of A is solution. From the probability of B complement intersection A given by probability of A minus probability of A minus B, this implies that the probability of A, if we make probability of A the subject, it will be given by probability of B complement intersection A plus probability of A intersection B. And substituting the values of probability of B intersection A and probability of A intersection B as given, we have 3/20 plus 1/4, LCM 20, divided by 21 times 3, 3, plus LCM 20 divided by 4 is 5, times 1 is 5. 3 plus 5 is 8. 8/20 reduces to 2/5. Answer C. Question 39. Given that a random sample of size is taken from a population with mean 80 and standard deviation 20, the distribution of the sample mean x bar is solution. Given any normal variable x with population mean mu, standard deviation sigma, and sample size n, the distribution of the sample mean x bar is always defined by x bar is normal with mu and sigma squared over n. Now, mu is equal to 80, sigma is 20, giving sigma squared to be 400. N is equal to 100. Substituting these values in mu and sigma squared over n, we have that x bar is normal with mu, and mu here is 80, and 400 over 100, which reduces to x bar normal with 80, 4. Answer C. Question 40. Given that x is normal with mean 48 and variance 16, the standard deviation of x is solution. Recall, for any normal variable x, the distribution is given by x normal with mean mu and sigma squared, where mu is the population mean and sigma is equal to the standard deviation. Now, x is normal with 48 and 16, thus giving mu squared, giving sigma squared equals 16. And if we take the square root on both sides, we have sigma equals 4. Answer 4. A. Question 41. A random variable which follows an exponential distribution has probability density function f of x, defined by f of x equals 3e to the negative 3x. The variance of x is solution. If a random variable x follows an exponential distribution with PDF f of x equal lambda e to the negative lambda x, then the expectation of x is lambda. The variance of x is 1 over lambda squared. Now f of x equal to 3 e to the negative 3 lambda, implying that negative 3x, implying that lambda is equal to 3. Substituting the value of lambda equals 3 in this var x, we have that var x will be equal to 1 over 3 square, which is 1 over 9. Answer B. Question 42. For a certain distribution, the equation of the regression lines of y on x and x on y are y equals 0.704x plus 7.703 and x equal 1.140y minus 1.11 respectively. The product moment correlation coefficient for this distribution is solution. Given the equations of two regression lines, y on x such that y is equal to bx plus c, x on y such that x equal to dy plus k, then the product moment correlation coefficient R will always be given by R equals the square root of the product b and d. Now, for the given equations, y equals 0.704x plus 7. That's y equals 0.704x plus 7.703. This implies the coefficient of x, b, which is b, will be equal to 0.704. And giving x equal 1.140y minus 1.11 implies the coefficient of y, which is g, will be equal to 1.140. Thus, R will be equal to the square root of the product 0.704 times 1.140. Simplifying this gives 0.8958571, which approximates to 0.896 to 3 decimal places. Answer A. Question 43. Given that x is binomial with parameter m 0.8 and expectation of x, and that the expectation of x is equal to 16, the value of m is solution. If x is binomial with parameters np, then the expectation of x is np. The variance of x is np-q. Now, x is binomial with parameters m 0.8, and given that the expectation of x is 16, that is, equating these parameters, we have that n is equal to m and p is equal to 0.8. Knowing that the expectation of x is np and substituting n and p with the values above, we have that m times 0.8 giving us 16, which is the expectation to be equal to 0.8 times m. And if we solve now, lambda x two values equal to the sum of all the 5 values, that's summation x over 5. This implies that summation x is equal to 5m. The mean capital M of a set of 8 values is equal to the sum of all the 8 values over 8. That's why we have summation y representing the sum of the 8 values over 8. M, capital M, given to be 16, implies that summation y is equal to 8 times 16, which is 128. Thus, we know that the combined mean, the mean of any combined set of 2 sets of scores is always given by the summation of the first set plus the summation of the second set over the sum of the 2 number of elements in the sets. So combined mean C is equal to summation x plus summation y over 13. C is equal to 17. That is, we are saying that summation x plus summation y over 13 is equal to 17. Cross multiply by 17. and that gives summation x plus summation y equals to 21. We replace summation x and summation y with the values obtained above. Summation x is replaced by 5m, summation y is replaced by 128, and if we simplify by sending 128 to this other side, 5m will be equal to 93. Dividing both sides by 5 gives m to be 18.6. Answer A. Question 46. A hypothesis is designed to test a claimed population mean of 420. A random sample of size 100 drawn from that population had a mean of 423. If the population variance is 144, then the test statistics for the test is solution. Test statistics for a sample mean x bar with population mean mu, sample size n, and variance is given by z equals x bar minus mu over sigma over the root of n. In this case, our sample mean is 423. Our population mean is 420. The variance is 144, implying that the standard deviation is 12. The sample size is given to be 100. Thus, substituting all these values in z, we have that z will be equal to 423 minus 420 over 12 over root 100, which is equal to 3 over 12 on 10, which is 30 on 12, which simplifies to 2.50. Thus, z is equal to 2.50. Answer A. Question 47. The table below shows the rankings of 4 contestants by 2 judges, X and Y. Rank X is 1, 2, 3, 4. Rank Y is given by 1, 2, 3, 4. The Kendall's coefficient of rank correlation RK for the above data is solution. Generally, for Kendall's coefficient of rank correlation, RK equals, for Kendall's coefficient of rank correlation, RK is always given by 2s over n into n minus 1, where n is the number of ranks. S is a score to be calculated based on the sizes of the relative ranks. Also, it should be noted here that when calculating Kendall's coefficient of rank correlation, these 2 conditions must be verified to see if we can easily state the answer. If both ranks are the same, then the rank correlation RK is equal to 1. But if one ranking is in the exact reverse order of the other, if one ranking is in the exact reverse order of the other ranking, then RK is equal to -1. And if none of the above condition is observed, then we simply use the formula to calculate the Kendall's coefficient of rank correlation. Now, observing these 2 sets of rankings, we see that the scores in the question have exactly the same ranks, implying that RK is equal to 1. Answer C. Question 48. A population has mean, mu, and standard deviation 4. A random sample of size 64 taken from this population has mean 24. A 98% confidence interval for mu using the sample is solution. A 95% confidence interval for the population mean mu obtained from a sample mean x bar of size n with standard deviation sigma is always given by mu, such that mu lies between x bar minus 2.326 times sigma over root n and x bar plus 2.326 times sigma over root n. In this case, our x bar is 24. The sample size n is 64. The standard deviation is 4. Substituting all these values in this interval, we have that mu will lie between x bar, which is 24 minus 2.326 times 4 over root 64, and 24 plus 2.326 times 4 on root 64. And this one simplifies to, if we use our calculators, this one simplifies to 22.837. And this other one simplifies to 25.163, which means that the population mean mu lies in the interval 22.837 and 25.163, which is an open interval. Answer A. Question 49. A continuous random variable x has probability density function defined by f of x equal 1 over 4 into 4 minus x. X lies between 1 and k. The value of the constant k is solution. If x is a distribution of a continuous random variable with PDF, f of x, then the integral from 1 to k, f of x dx must be equal to 1. Now, f of x equal to 1 over 4 into 4 minus x, x lying between 1 and k and 0 otherwise. That is, the integral from 0 to k, f of x dx is equal to the integral from 1 to k, 1 over 4 into 4 minus k minus x dx. Now, to integrate this, we factor add 1 over 4, and integrating 4 gives 4x, integrating x gives x squared over 2. Limits from 1 to k. Substituting the limit and simplifying, we have 8k minus k squared minus 7 all over 8. Thus, we were told that this integral must be equal to 1. Thus, therefore, we equate this expression to 1. 8k minus k squared minus 7 over k is equal to 1. Implies that if we divide all through by -1 to make this coefficient of the leading variable, the coefficient of this leading term, k squared to be positive, we have that k squared minus 8k plus 7 is equal to, cross multiplying this by 1 will be 8, and dividing by the negative give -8. So making it in a standard quadratic, we have k squared minus 8k plus 15 is equal to 0. And looking for factors of 15 whose product will give 15 and whose sum will give -8, we have -3 and -5. This is how we factorize. And if we factorize this, having this linear product of factors, or this product of linear factors, we use the principle of factorization to get the values of k, which gives k equals 3 or k equals 5. But in this, our alternative, the only alternative that has been given is 3. Thus, answer B. Question 50. To estimate the variance of a population, 2 independent random samples drawn from it produces the following results. Size, variance, sample 1 of size 40, the variance is 1.194. Sample 2 of size 50, the variance is 1.724. An unbiased estimator of the population variance is solution. An unbiased estimator of population variance, also called pool variance, is given by sigma cap squared equal N1 S1 squared plus N2 S2 squared all over N1 plus N2 minus 2. Now this N1 is the size of the first sample, and this S1 is the sample variance. N2 is the size of the second sample, and this S2 square is that sample variance. Now substituting and using the table to substitute these values, we have 40 into 1.197 plus N2, which is 50 into 1.724, all is over 40 plus 50 minus 2. Using a calculator to simplify this, we have sigma cap square is equal to 1.52227 continuous, giving sigma cap squared to be approximately 1.52 to 2 decimal places. Answer A. So please, we have come to the end of this statistics revision past question of 2021. Now, if you did not subscribe at the beginning and you are not part of my channel, make sure you don't forget to subscribe before you end the lesson, so that whenever future lessons are prepared, you will always be part of the lessons. Thank you, and thank you once again for viewing. If there are any proposals or any recommendation, any suggestions, or any question that was not well understood, please leave it in the comments section, and I will get to you through the comment section.